So we're going to talk, as I said, about QoE metrics reporting for 5G media streaming. And I'm not going to dive deep into the architecture. I would refer to, first of all, our website for details, because we have some explanations on the website. We have explanations on the documentation website for the 5G Mac reference tools. And there's also a getting started guide on how to set up the whole 5G media streaming chain. And then more or less what I'm explaining today is built on top of that. So just one slide for you to understand what we're going to talk about and what I'm going to show you. We are diving into, as I said, QoE metrics reporting. And this is an important feature for application providers and content providers, because the main idea behind QoE metrics reporting is that during a streaming session, you collect certain metrics, like, for instance, the buffer level, which representation, so which quality was selected, and you report that back to a server-side component for analysis later on. And this is something that is more or less used in production by all of the different content providers. There are some commercial solutions like Conviver that focus exactly on that. And there are also different metric reporting schemes, and we're going to dive into more details as part of the demo. If you look into the architecture of 5G media streaming, you will find multiple components being involved here. And as I said, this is really a joint work that I'm going to present today. So if we start on the core side, on the server side, if you look into the right side of the diagram here, I'm going to zoom in a bit. You can see that we have our application function that was developed by the BBC in the reference tools. And there's also Vuk from Fraunhofer working on specific aspects of the application function. And the first thing we need to do in order to enable metrics reporting later on the client side is we need to provide a certain configuration to the application function. And this is done via the M1 interface. So we already have multiple features that are implemented on the M1 side. And this configuration for the QoE metrics reporting was one of the missing things that has now been added mainly by Vuk. So we start here on the right side as an application provider. We provide a configuration for metrics reporting via the M1 interface. And then the information we provide here is more or less put into the service access information that serves as a foundation for playback on the end device. So typically we do the configuration via M1, and then we start a streaming session, and the client, as one of the first steps, the media session handler located here on the client side, is fetching the service access information, gets the required metadata. And as part of the service access information, we will have information about, for instance, which metrics to report during the streaming session, where to report them, when to report them, and how often to poll certain metrics on the client side. So all of this is included in the service access information. And then while we are doing playback, we're going to collect these metrics on the client side, and we're going to dispatch them via the M5 interface to the application function. And in a very simple implementation, we just save the metrics report to disk, and we can later on analyze these metrics report, correlate certain streaming sessions, and more or less check if the streaming session works well or not. So this is what we implemented. As I said, we need to touch multiple components, and I'm going to walk you through the different steps that are required in order to enable this. One thing I didn't mention so far is that in theory, there is the possibility to, let's say, enable multiple metric schemes. And we're going to focus on the default scheme, which is this one. No need to more or less remember this. But keep in mind that this is the default scheme for 3GPP Dash. This is the specification, and there's a link to the ISO specification for Dash as well. So that's 23009-1. In the NXD, you find all of these metrics. And if you check the corresponding 3GPP Dash specification, you'll find the metrics that we support currently. Okay, so I'm going to walk you through this, and let me quickly explain the setup that we're going to use here. So I have my Mac machine that I'm using for sharing right now. I have an Android device connected to the Mac, which actually disconnected. So let's see if this worked later on, but that's the Android device I have here. And then we have a Linux laptop next to me, which I'm using for hosting the AF and the AS, so the application function and the application server. All right. In order to show you this, I established a remote desktop session to my Linux machine next to me. And for the setup, the application server is already installed. The application function is installed. We're going to go step by step and do the necessary configuration and show you or walk you through the final metrics reporting. So first thing we need to do in order to make this work, we're going to start the application server. So that's a simple command. We have installed it before. Application server is running now. By the way, let me know if something is not working. So right now you should be seeing a Linux screen, my remote desktop connection. So the next thing, we're going to start the application function. Again, simple command after installing it. So it's installed in the binary folder here. We're going to start this one as well, and it is running. All of the configuration that you need to do and also to access this application function from a different machine can be found in our documentation. So this is really, I just walked more or less through our own documentation here. Now we have those components running, and what we need to do now is we need to apply some basic configuration. So we need to create a provisioning session, a content hosting configuration, and we also want to create a metrics reporting configuration, all being done via the M1 interface. So you can do that more or less manually, step by step, by sending REST calls to the M1 endpoint. An easier way is to use one of the Python tools that David implemented. And the idea behind these Python tools is to use a JSON as an input, specify all the required information in this JSON file, and then run the Python tool that parses the JSON and does the necessary M1 post calls to the application function in order to do the setup based on the information in the JSON. So I'm going to show you quickly how this JSON looks like that we are using for the configuration right now. And I hope you can read that. I don't know how to change the colors here. I hope the contrast is fine. It's really nothing that special. So if you look at the bottom part here first, we find different VOD media, so different MPDs that we are later on going to offer for playback. Those are 3 different MPDs, Elephant Stream, Big Bug Bunny. Don't worry, I'm not going to show you Big Bug Bunny, and test card. So 3 different contents more or less. And then for all of these contents, we're going to add some basic configuration options. And the one that is important for today is this metrics reporting configuration here. So you find also consumption reporting. We talked about this previously, not going to cover this today, but the metrics reporting configuration is the one that we need today. I have to add one remark here, because at this point, the Python tool that we're going to use in a minute does not support this metrics reporting field here. This is something that FOKUS is currently working on. So we still need to do like a manual step, and I'm going to show you how to do this. But in the future, and I also think with the upcoming release, the Python tool will recognize this new attribute here and do the configuration based on this JSON file. But for now, keep in mind that this attribute is ignored, so we need to add a manual step here. All right. So I'm going to close this, and I'm going to run the Python tool that reads in the JSON file and does necessary configuration for us. So let's run this. And then you can see the basic output here. So we created the provisioning session. We created the consumption reporting configuration. And in the future, there would also be like a metrics reporting configuration once this new field is supported. Here's also the content hosting configuration that I didn't mention right now. All right, so that's the basic setup. Now I'm going to switch back to my MacBook, and I'm going to show you how we add this metrics reporting configuration that we still need in order to do metrics reporting. So I'm going to jump into Postman. And for everyone who has not seen this before, we actually shared this, I think, in the last public call. That's another way to kind of control the behavior of the application function. We defined some routes here in order to control the different functionalities of the application function. So there are predefined routes for the M1 interface and also for the M5 interface. And you can add provisioning sessions, consumption reporting configurations. And what we're going to use right now is the metrics reporting configuration here. I need to take one extra step here. So what I'm going to do now is I'm going to share quickly the browser. Sorry for jumping between all these windows. Because one thing that the Python tool is doing for us, it creates an M8 file. And the M8 file is an important input for the client later on to know about the available provisioning session IDs. And we actually need this provisioning session ID right now as well to create the metric reporting configuration. So I'm going to copy this out here. This is all based on our previous JSON input and the Python tool that we used. And I'm going to put this into my Postman. And the great thing about Postman here is that we can define variables. So I don't need to add this provisioning session ID manually to all of my calls. I simply add this once here as an environment variable. I'm going to save that. And then later on in the different routes, for instance, if I want to query a provisioning session ID, I can add this placeholder and it will automatically be updated based on my environment variable. So I'm going to do this now just to show you that this works. And you can see that the query was successful. So we can query the information for a certain provisioning session ID. All right, so as I mentioned in the beginning, the first thing that a client is doing is fetching a service access information. So we're going to do this now just to show you how the current service access information for this specific provisioning session looks like. And it kind of looks like we expected because we provided a consumption reporting configuration before as part of the configuration step. So this is included here. And you can see that the metrics reporting configuration is missing right now. And this is something that we're going to add manually now. So I'm going to go back to the M1 tab here. I'm going to select metrics reporting, and I'm going to create a valid configuration. And there are certain fields that you need to transmit to the application function for the configuration. So I'm going to omit the scheme for now. And if you omit that later on, it will be populated with a default scheme. I'm also not going to specify a data network name, but I'm going to tell the application function to set a reporting interval of 10 seconds. So basically the client is reporting the metrics every 10 seconds. Then we have a sample percentage of 100, meaning that all of the clients are supposed to send the metrics during playback. We're going to apply no filters for the endpoints. We're also going to sample metrics like the buffer level, for instance, for every 5 seconds to have a good amount of data. And then we're going to specify here which metrics we want to report. We could also leave this blank, which means that all of the metrics are will be reported. But in this case, I specified all of our supported metrics, which is HTTP list, buffer level, representation, switch list, and MPD information. So all of them are going to be collected on the client side and then reported back to the application function. So if I fire this now, it gives us a 201 response code. So that was successful. If we query the service access information now, we have this missing field. Sorry, I'm trying to increase this a bit. So we have this missing field. We have the client metrics reporting configurations area with one configuration. And the scheme got auto-populated to the default one, which is the CDPP DES scheme. And then we have all the other parameters being used as we specified them before. Okay, so these were the necessary steps in order to do the configuration on the application function side. So we used M1 and we queried the information via M5. The next step is to actually run a client on the Android device and have it report the metrics. So I'm gonna start my Android Studio now. And for sharing, I'm gonna also copy the screen of the Android device. There was a typo, screen copy like this. Okay, so this is the device I have located next to me. And first thing I'm going to do is I'm going to start the media session handler on this device. Takes a few seconds to build. Media session handler is running. Now we start the 5G middleware application that includes also our media stream handler. And that is connecting to the media session handler right now. Okay, and if you look at the right side of the screen, I'm sharing my code editor here. And there's a small configuration file that we typically use. And this allows us to specify multiple endpoints. Basically endpoints from where the M8 information is fetched. So there's a hosted endpoint on the 5G MACLI node. And the one that we are going to use now is this one here, which points to my Linux machine. So that's the IP of my Linux machine. Sorry, the device went off. Okay. So I'm going to select the one from my Linux machine, and then you can see that the three streams we configured are selectable here. So Elephant Stream, Big Bug Bunny, and Test Card. And we're going to select just the first one here. Start the playback. If this works. Currently it's not working. Check. Maybe there's a connection interruption.
I think you had some warnings earlier about the AF connecting to the AS.
Oh, that's the nice thing about doing a live presentation. It worked before. Let me check. There are some warnings here, but that's related to the NRF.
No, it's failed to connect to localhost port 7777, which is the AS.
That's weird.
So if you check the AS's screen, it should say it was listening on localhost port 7777.
Yeah, it's here.
Yeah, although one's using IPv6 and the other's using IPv4. Don't know whether that's your issue.
So I have a video as a fallback. Let me just quickly try to do the setup again, because it was definitely working before. There's connection refused here. Otherwise, I'm going to show you the video, but I wanted to really show you this live. Let me check. Where's the post menu? Oh, no, I need to do the editing again. So that definitely worked. Okay. Then let's check this again. No, I think we have a problem here, but I'm not sure why.
What is the M3 host setting in your AF configuration?
I would need to check, but I definitely tried this before the call and it was working with the same configuration, which I find a bit confusing now.
Yeah, I'm wondering whether if you've put localhost in, it's randomly picking an IPv6 or an IPv4 address.
Okay, but now I think we have it working. It's definitely, yeah, I think that's fine now, whatever the reason was before. Okay, sorry for the delay here. So the video is playing now. And if you remember back to our configuration, we were reporting metrics every 10 seconds. So I'm going to play this now for, let's say, 20, 25 seconds. And then we're going to look at the actual reports. So I think that should be sufficient. Now, we have to move back and keep this provisioning session in mind, GA7001. So we're going to move back to our Linux machine now, because what we are doing right now is we are taking these metrics report that are sent by the client, and we are just writing them to the disk. So if we go back to the Linux machine, there's a folder which is labeled var local log open5js reports. And there you find a dedicated folder for all of the different provisioning sessions that we ran. And if we cd now into the one that we just saw, which should be this one, there should be a folder for the consumption reports, all the consumption reports that are stored, and also the metrics reports. So we're going to go into the metrics reports folder. And there we got our metrics reports. And they are currently based on an XML format. So we're gonna show you how this looks like. I'm gonna do a bit of copy paste action here. So I have an old one here, but we're gonna use one of the new ones here. So this is how it looks like. Let me copy that out. Go back to Android Studio. Then we can create a Scratch file, paste this here, format this, and then it's much better readable. All right, so this is how it looks like today. We support 4 different metrics. It's an XML-based format, so nothing that special. What you will find in the report is a client ID that does not change unless you connect another device. What does change for each streaming session is this recording session ID. So you can kind of correlate different streaming sessions to the same end device, to the same client. And then you have default parameters like the report period, the report time, and the first real metric is the buffer level metric, which simply gives you the buffer level at a certain point of time. And this will increase, obviously, as soon as the player buffered for some time. One thing I wanted to add here, what you might be missing, is that this is the combined buffer level for audio and video. So there's no specific type being specified here. This is audio buffer level, video buffer level combined, because you need obviously both types of content in order to play your video. If you have an MSE-based client, as soon as one of the buffers is empty, playback will stall. So this is the combined buffer level of audio and video, like the common minimal denominator of both. And then we have the HTTP list metric. And again, minor warning here, this is not a CDPP-compliant metric anymore. I did a mistake when I was implementing this. I implemented that and I missed that the specification actually removed this metric at some point. Still, I thought it might be a waste to kind of discard the implementation. So if you today explicitly enable this metric, it will still be collected and then also reported. And what this gives us are the different request types that we are sending out. So requests to the MPD, requests to initialization segments, or also to media segments. So all of this is logged here with the corresponding byte size and the duration of the request. So maybe that's quite helpful in some cases. And then we have two additional metrics. So one is MPD information with information about different representations that we selected. So for each representation switch, at some point you will see this MPD information tag here that gives you information about the representation itself, like the bandwidth of the representation, the codec, the MIME type. And in case of video, you also have like the width and the height and the frame rate. So more or less metadata that allows you to check which client selected which representation and which quality more or less was played. And then related to that, all of the different representation switches over time. So when the client is selecting a new quality, there will be one of these rep switch events in the logs here, and you know exactly when the client was playing a certain quality. So that is the XML-based report. And what I thought might be interesting as well is what can you do with this data? So one thing I did was like quickly set up a minor, it's kind of a static UI, but it takes one of our reports. This is an old one I created before, and kind of visualizes the data here. So we have the static data like the client ID, the URL to the MPD. We have, again, static data, the session ID, report period, and report time. And then this information about the MPD, the different representation IDs also listed here with the corresponding bandwidth, codecs, and MIME types. And I think what gets more interesting is, for instance, if you look at the buffer level. So this is the buffer level that was building up over time, and it went up to almost 60 seconds ahead buffer, which is a player setting. So basically, you can specify this in your settings of the player, how much forward buffer you want to create. And this is a good metric in order to check if your client at some point was running into an empty buffer and maybe the playback stalled for some reason. So very important metric for debugging. What I also thought might be interesting is checking or correlating the duration of a request with the transferred size, so the bytes of the request. What I find quite interesting is I'm not sure if you can see this, I hope so. If you look at the top here, the MPD requests are depicted in blue, initialization segments in red, and media segments in orange. And you will find, for instance, the MPD request down here. So although the MPD is quite small in size, it almost took 600 milliseconds to fetch this MPD, which is quite long. So maybe there's something delayed on the server side when it comes to the MPD requests. And then you'll find the initialization segment requests down here at the bottom left. So this is what you would expect. Small size of the initialization segment and corresponding also small request duration. And the orange dots down here are probably audio segments. I cannot really tell the type here because I did not plot that, but this should be the audio part. And then you have the scattered dots over here, which should correspond to the video segments because they are much larger in size if you compare them to the audio segments. And they're also quite different in terms of the request duration. And last metric is the representation switch metric. more or less also what we would expect. So we select an audio quality at the start. We stay at this audio quality for some time. It's a blue dot down here. And then for the red dot, we start with around 8 megabit and we move up to almost 13 or over 13 megabits, which is quite high. Actually, that's quite a lot. Anyway, so you can also plot the different representations that were played over time, so you get a feeling of the quality of the streaming session. All right, this was all I wanted to share. So this has all been merged to the development branch. All the work that Vuk, Dev, David, and Richard were doing on the application function side in terms of metrics reporting is now merged. The client-side work that I was focusing on is merged to the development branch. We have release candidates for the application function and for the client-side components that you can test. And if you're interested in that, it would be great if you set this up and let us know if you encounter any problems. As you saw today, there might be some problems with the playback from time to time, but in general, it seems to work really fine, and we have the reports coming in, and the data looks valid and reasonable. All right, one final thing that I wanted to say, we have a dedicated project board for this. So all the QoE metrics reporting stuff is in this project board, and we are not supporting all of the different metrics today. So there's still room for improvement. Missing features, for instance, the initial playout delay metric, device information, playlist metric, average throughput metric. So if you're interested in supporting us here, just pick one of these issues. The implementation should be pretty straightforward if you know how to derive the information, because the current architecture on the client side is very modular. We're using dependency injection, we're using interfaces, so more or less can plug in your own metric scheme handler, but you can also enhance our current metrics with these missing ones for the default scheme of 3GPP Dash.